There's a lot of buzz around data and analytics these days, and by now, you've probably heard of something called machine learning. But what exactly is machine learning, and how do researchers use it? Broadly speaking, machine learning uses computer programs, as opposed to humans, to identify patterns in data. In many ways, machine learning automates things that researchers have done for years. For instance, we often ask people taking our surveys to tell us, in their own words, how they feel about a particular issue. A researcher then reads all those responses, identifies key themes, and organizes those themes so we can analyze them. But what if we wanted to analyze, say, several million social media posts, or tens of thousands of lengthy congressional speeches? That level of scale and complexity is much more difficult for humans to process. In these types of situations, machine learning can be very useful. To help us understand how researchers use machine learning, I've asked Patrick Van Kessel from our Data Labs team to explain further.
At Pew Research Center, we typically used supervised machine learning, where researchers train a computer algorithm to identify important concepts based on their own knowledge of the subject and goals of the research. These models can then be used to measure concepts in large pools of data. And we've used this method to measure things like what people are talking about on social media, or who appears in an image. Let's walk through an example. In one of our recent projects, we wanted to look at how often members of Congress express support for their own political party when they post to Facebook. Normally, we would have our own researchers label the post themselves, but in this case, we collected hundreds of thousands of posts. To be able to analyze data at that scale, we need a way to pick out posts that contain supportive language automatically. One option was to pick out posts by looking for certain keywords. For example, if a member of Congress mentions their own political party in a post, there's a good chance that they're being supportive. Similarly, if a post uses the word wonderful, the legislator is also probably talking about something supportive as well. But even though these may be helpful indicators, it's really difficult to come up with a set of rules to pick out supportive posts reliably without making a lot of mistakes and without missing any posts. For example, the word wonderful can also appear in contexts that are not about expressing support. And there are many other words a politician could use instead of wonderful to express support as well. Rather than trying to come up with every possible keyword and establish complicated rules ourselves, we turn to machine learning. So how did we do this? First, our researchers labeled a few thousand posts themselves to serve as examples of posts that expressed support and those that didn't. We then provided these examples to a machine learning algorithm, which was able to learn by itself which words in the post were associated with support. Using that information, it was able to formulate a set of rules to mimic our own decisions, which we could then apply to all of the posts. Of course, it's important to check whether machine learning predictions are accurate and unbiased. Whenever we use these tools, we measure how well they perform and are transparent about their shortcomings. As part of this process, we always compare a sample of the algorithm's predictions to our own decisions and compute its overall accuracy along with other performance measures like precision, which tells us how many predictions it got correct, and recall, which tells us how many cases it missed. Since even well-trained humans make the occasional mistake, it doesn't have to be 100% perfect. We just need to be confident that our algorithm can make predictions about as well as we would ourselves.
Thanks, Patrick. Ultimately, machine learning doesn't replace the need for human researchers, but it can expand our capabilities and enable us to explore data on a scale that otherwise wouldn't be feasible.